Hello and welcome to the fifth lecture in fourth chapter of our comprehensive course on machine learning, data science and artificial intelligence. Now here we are discussing about Numpy and previous lecture discussed these basic built-in functions which are provided with Numpy. Now we take up the discussion further and take some basic examples. Initial examples are very easy and thereafter the examples become slightly more and more complex. Also, so far we have discussed only 1D array, but now in some of the example 2D and other dimensions will also be included. So first is very easy. This is a list. This is the standard way of creating a Numpy array. That you write np.array. Of course, you have to import Numpy in the beginning, and then write np.array, and in the parentheses write the list. So it will create that array. Now there is nothing much complicated about that. Okay, so fine. But starting from here, now here if you see, you have to see it is looking like almost the same syntax, numpy.array 1 2 3, but this is actually now not a list, but it is a list of two lists. Okay, so outer is a big list, and each member of that outer list is independently one list. This is the first list and this is the second list, and two lists are comma separated in the outer list. If I want to clearly distinguish, then often you can write like this, so that clearly you can see that there are two lists which are inside a list. So this number of these square brackets that decide how many dimension will be there. Here there is only one square bracket, so it is a 1D array like this. But this will create a two-dimensional array, and its first row, or that is 0th row, will be 1 2 3, and its next row will be 4 5 6. Okay, let us see it. It will not look exactly as we would like to see. For example, it looks somewhat this way. Okay, so mentally you have to shift this 4 5 6 below it. Then it looks proper two-dimensional array. What I am saying is something like this. This is the output which we got. I actually copied this output from that Jupyter cell itself. Now this output is actually of this kind of two-dimensional array. Okay, so 1 2 3 4 5 6. So that means this 4 5 6 is below 1 2 3. That means this is 0th row and this is the first row. Similarly, if I show by another color, then this is the 0th column, this is the first column, and this is the second column. So what kind of array this is? Then this is a 2 by 3 array. That is, it has 2 rows and 3 columns. And this product, if you do 2 multiplied by 3, that must be equal to the total number of elements inside. So that 2 multiplied by 3 is equal to 6. And total number of elements were also 6. Let me undo a few things. And you can again see that total there were 6 elements. Okay. So 1 2 3 and 4 5 6. So it is a two-dimensional array of 2 rows and 3 columns. Fine. Now np.zeros we earlier saw, but at that time I specified only np.zeros 3. That means a 1D array of 3 members. 3 zeros like this. But if you specify np.zeros again and specify dimensions in this manner, remember this is not list. That means it is not this kind of situation. Okay, so you have to understand that and see carefully. So this is a parenthesis which is specifying the dimensions. So what it will create? It will create array filled with zeros, 0.0.0, which will have 3 rows and 4 columns, or total that means 3 multiplied by 4, that is 12 elements. Okay, and you can see that it is creating that. Again, mentally you should shift this below this. So then, and these also exactly below this, then you will be able to clearly see that it is a 3 rows, 0th row, first row, this is 0th row, this is first row, and this is second row, and similarly 4 columns. This is 0th column, first column, second column, and third column. Okay, so that is the array of zeros. Similarly, I can create np.ones. Earlier we created np.ones in last lecture, but there I specified only one dimension, 3. So this kind of array was created. But if I specify np.ones and then 2 3, now you can, I will pause for a moment, you think what kind of array will be generated in your mind. Okay, so that will be a 2 rows and 3 column array. That means ideally I should expect something like 1.1.1, 3 columns, below which another 1.1.1, 2 rows. Okay, and you will see that exactly that kind of array is generated, 1.1.1, below which another 1.1.1. Okay, fine. Now more important are these two, np.arange and np.linspace or line space as some people speak. These are very important functions which are used in Numpy. When that, what is the speciality of this function, or when to use which, that is important. So arange is used when you know starting point, then you know end, and you also know the step size. Step size means, in this case for example, I know that I want to create numbers starting from 10 to 45. Say. Why 45? And then I have written 50 here, I will tell you. But I want to create 10 to 45 numbers with gap of 5. That means I want to create something like this, 10, 15, 20, 25, and 30, 35, 40, and 45. This kind of thing. Okay. So question is, will I write every time? I can write np.array, and in that I can write this whole list, but that would be too tedious. If I already know where I want to begin, I want to begin at 10. And if I know my step size and I know where I want to end, my numbers should be less than 50. So the characteristic about arrange function is that whatever you specify at the beginning, that will be included in your result. But whatever you specify as the end, that may or may not be included depending upon your step size. Okay, so it is possible that while arranging in that kind of steps, the last number is not included. In fact, it will never be included with arrange. So you can see I can still add 1 5 in that, but the result of this will not be this kind of array, but it will be this kind of array. And I will show you just now. So what is this? This is the starting point of your array. This is the ending point of array, excluding this, and this is the step size. Or how to read this whole thing? Then create an array starting from 10, reaching up to 50, but not including 50. And the difference between consecutive members should be 5. Okay, let me show you. Okay, so it shows that exactly. Now then, what is linspace? Linspace and when to use it? So again, when you know start, when you know end, but you don't know the step size, but you know how many steps or how many members you want. So how many steps is also wrong, but how many members you need. Okay, then you will use this linspace. For example, it will create a kind of linear array starting from this number, ending at this number. Now that is one important difference between linspace and arrange. That in arrange I speak that starting from 10, reaching up to 50, but not including 50. While here in linspace I will speak starting from 0, reaching up to 2, and including 2. So there is 2 last will also be included. And how many steps should be there? Then total 9 members should be there in between 0 and 2. So it will adjust the step size automatically based on how many members you need. Okay, so you don't have to specify what should be the gap between consecutive members. You have to specify instead how many members do you need. And you can see it has adjusted the gap that 0.25, 0.5, 0.75. And if you count this, how many members are there, then it will be total 9 members. Okay, so this is the difference between these two. Here, the number of members are not in your control, np.arrange. It automatically adjusts the number of members depending upon the step size. For example, if I just put step size of 10, then what will happen? Then let us see. Then I get only 4 members. Okay, so because now step size is 10, so after 10 next will be 20, after 20 next will be 30, after 30 next will be 40, and this 45 will also not be there. And with arrange, the last number of the series, whatever you have specified ending point, that will never be included. Now here, how many members will be created with arrange? That is not in your control. Numpy will automatically adjust the number of members. But with arrange, what is in your control? What will be the gap between consecutive members? With linspace, it is reverse. Number of members are in your control, but what will be the gap between them? That is not in your control. For example, here number of members I just write 4 because I want to create array. Then someone says that create array including 0 to 2 and include 4 members, or say 5 members. Then okay, so 0, 0.5, 1, 1.5, and 2. Fine. This kind of thing is required when you are asked that famous type of question that how many points will be required to divide a line in 5 equal parts. So many people give wrong answer that 5 points will be required, but no, you can see that 4 members will be required. Okay, sorry, not that question, but here I think, yes, here. So if you want to divide the line between 10 and 50, how many points will be required? Then 4, because 50 is already existing on that line, that is why. Okay, so these two you must remember. Here, what is in your control? The gap between consecutive number. And in linspace, what is in your control? The number of elements in the array which you are creating. Then what is not in your, second thing, what is the difference between arrange? In arrange, the last point is not included in the answer. In linspace, the last point is included in the answer. Okay, fine. Now, this reshaping the array. Now, this reshaping is also important because sometimes you have created an array like this, but later on you realize that you want to convert it into a 2D array. That means 10, 20, first row, and below is second row, 30, 40. So will you again create array from scratch? No, you can just reshape by specifying the new dimension. How? This is the same example, and this is np.arrange 1 to 30. Now this is also one important characteristic of arrange function, that this gap between consecutive members is not compulsory to specify. Here you can see I have not specified any gap. Then it takes the default gap, and the default gap for the arrange function is 1. So it will create 1, 2, 3 up to 12. Okay, it will create something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Last number is never included in the arrange function. So default step size is 1. If you want different step size, then you have to explicitly specify that different step size. Okay. So if you create this array, then first let me print this array. This many lines I first take it in the another. Let me print this array and check if we are getting what we want or not. So we are getting fine. Now I'm asked that okay, this was a one-dimensional array, but convert this into an array of 3 rows and 4 columns. Then will you mentally, create a new array by creating a list of lists? If you remember, somewhere here we have done assets that how to create a multi-dimensional array list of lists. But I do not need to start from the scratch. Okay. Instead, I can just write the original array, whatever is created, 1D array, dot reshape and specify what dimensions you need. So I need 3 rows and 4 columns. So I will simply say the original array, first create a 1D array and then specify it in the 3 rows and specify 3 rows and 4 columns. Okay. And if I write it, then you can see it is 1, 2, 3, 4. Mentally shift this below this and shift these also below this. So then you will easily able to see that this is the first row, this is the second row, and this is the third row. Similarly, this starting from 1, 5, 9, that is the 0th column or first column, whatever you want to say. Then this is 2, 6, 10, that is the next column. Then this is 3, 7, 11, next column. And this is 4, 8, 12, that is still next column. Okay. So 4 columns are there and 3 rows are there. Now there is one more thing which I want to show here. That reshape the array, here we created in 2 steps. But every time, once you become a seasoned programmer, you say I want to create same array in just 1 step. Then what I can do is np.arange 1, 13. That means I have created how much? When I do that, I have created this much. Now here only I put dot and then I write reshape and then I write 3, 4. You can see that this will also produce the same answer, reshaped underscore array 2. Okay, fine. So this will also produce the same answer, this same answer. In fact, this way, the format of the answer is better and more legible. Okay, here I tell you always that mentally shift this below this and mentally shift this below this. But if you do everything in 1 step, then Numpy even adjusts the formats for you. Okay, so this is one good trick, and you must understand whenever you see any such command. And seasoned programmers, please forgive me, but those who are completely new to programming, for them I'm saying, whenever you are saying this kind of command, then each dot is a separation point. Now here, for example, before the dot, what is there? That is the library name. Then before the next dot, what is this? This is the first function. So next dot will not apply to NP, but next dot will apply to the result of this. So mentally you should think what this will create. This will create an array of 1 to 13 number, not including 13 number. That means it is a 1 to 12 numbers with a gap of 1 because no gap is specified. That means that it is 1 default gap. So it is mentally you should understand that this creates this array, and then you should. So this reshape is acting on what? Reshape is not a function for NP library, but it is a function for array created with NP. So reshape will act on that array and it gives reshaped array. Okay, fine. Now this is one thing which I wanted to show. What more? Yes, but more thing is that standard way of creating seeing the documentation. For example, you forgot what is the difference between arrange and linspace. Nothing, no worry. Write np.arrange question mark and press Control Enter, and it will show that start, stop, and step size. Step size is optional, and that means default step size is 1. Okay, so it creates an array start with start and stop and default step size. It also gives examples, so you clearly remember that the end point is not included. For example, here 3 and 7, and no step size is given means 1. So 3, 4, 5, 6 will be included, but the 3 to 7, but not including 7. With arrange, you have to specify that way. And similarly, np.linspace, suppose you write and then question mark, then you will get all the details for that function. And there also example will clearly show that it will include the starting point, it will include the ending point, and it will also include the total number of members which you have specified between those 2 points. Okay, so somewhere here, for example, starting point is 2, ending point is 3, and numbers are 5. So total 5 members between 2 and 3. It will calculate the gap between the numbers automatically. While with the arrange, it will calculate the number of elements automatically. Gap between the numbers you have to specify, or it will take the default gap between the number as 1. Okay, fine. So that was some discussion about some basic functions. Okay, what we have done with arrange, if I want to show pictorially, or for that with that reshape, so I keep this too also, but that reshape I will move up. Let me delete these extra cells and this reshape. Okay, cannot move up. Fine. So I will delete this documentation part. Please remember that you can access the documentation by putting the question mark. Okay. What this arrange has done, that is shown here. Okay. First, it has created an array of 1 to 12, and then it has reshaped into 3 rows and 4 columns. very clearly visible when you write everything in one step. The advantage is that code is becoming small and output is becoming more legible compared to earlier case when you do it in two parts. Okay, fine. We will do, or let us continue. It is a little bit long, but this is required, so please bear with me. Now, suppose there is one more thing that NumPy has this one more facility also that you even can avoid specifying any one dimension. For example, here reshaped underscore array say 3 equals np dot arrange 1 to 13 and then dot reshape, and I just write 3 rows, but I do not specify columns. Instead, I write -1. Obviously, -1 column is not possible. So what does this -1 tell to NumPy? It tells that calculate columns automatically. How will it calculate columns? Because it knows that there are total 12 members. This much will create an array which is shown below in the diagram. So 12 members. If the rows are 3, then obviously 3 4s are 12. So next columns should be or must be 4. And you will see that if I printed it reshaped array 3, then you will get the same output. Okay. Similarly, you can avoid specifying the number of rows. For example, here only, but now reshaped array 4. And here this time, instead of rows, I specify -1, and instead of columns, I write 4. So then NumPy understands that rows are not specified, so I have to automatically calculate. And again, 12 elements and 4 columns, so obviously 4 3s are 12. So there must be 3 rows. And this will give same answer as earlier. So with reshape function, you can always avoid specifying any one dimension, and NumPy will automatically find that dimension. So that is here shown in example that -1 indicates that the second dimension is not shown, and it is calculated on the fly because there are 12 elements and 3 4s are 12. So NumPy calculates that the second dimension must be 4. This is the same example, and you can see that it is finding that. Similarly, there is one example picture I have given, so you should write the code. Please have a practice of typing the code a little bit, because AI tools and all these are fine, but you have to at least have your hand also, you get your hand a little bit dirty, okay? Because that builds a kind of muscle memory. Okay, we will start in next lecture with array indexing and slicing. Thank you.